Hello, good afternoon, everybody. So you've just heard a talk from Jonathan about the state of the Filecoin ecosystem, and he touched on a number of topics there, one of which was FVM, the Filecoin virtual machine. And I'm going to expand upon that a little bit further and talk about unlocking the open data economy with the Filecoin virtual machine. So just through here. So FVM delivers on-chain programmability to the Filecoin network, right? Just to recap again the kind of steps that we've gone through this three-stage master plan. Jonathan covered it just now, but it was build the world's largest decentralized storage network. Well, we've already done that, and we're still continuing to build upon that. So it's about 12 exabytes of data. That's 12 trillion gigabytes of data. It's about 1% of the total data center storage capacity worldwide at the moment. So it truly is a pretty substantial network. Step 2, onboard and safeguard humanity's data. Again, we're well on the way to doing that. There's a number of public data sets that are being onboarded. There's a number of organizations that are using Filecoin to store their data long term. And then step 3, where we are now, is compute. Bringing compute to the data, so doing useful work with that data. As Jonathan mentioned, data has gravity, and quite often it's easier to take the compute to the data than take the data to the compute. Especially if you're generating large amounts of data continuously. You get to a point where you just physically cannot move that data fast enough to the nodes where you need to do the compute. So you need to take the compute jobs to the data. FVM was launched just over a month ago. We're at about 400,000. Phil, actually that number has gone up, I think, even more since I wrote this slide. And we've got a number of accounts already on the network. We've got an initial batch of ecosystem partners that are building, some of which are actually here at Consensus, that are building on the network. And we've got a number of projects that have launched on the main net as well. So bridges, things like Sealer, Axler, oracles like Teller, for example. And we've got things like staking pools as well on there coming up. So really, FVM solidifies Filecoin as the layer 1 for unlocking and powering the open data economy. So what do we mean by this? So again, JV touched on some of these key pillars that we have on the network here. And FVM really enables a much more composable set of primitives that people can actually interact with these different elements and compose them and put them together in ways in which we ourselves have not even thought of some of them. So it allows you to kind of incentivize and orchestrate some of the key primitives that go behind storing data and the economy around storing data. So not just the mechanics of how you actually store data, but who stores that data, for how long, how much do they pay for it. And now any developer can interact with that. Any developer can now deploy smart contracts onto the Filecoin network to interact with that and build services that really capture the value around that data economy. So storage is one area, but as we can see, storage, retrieval, compute, we get into larger and larger economies with that data. And there's a number of aspects of that going through from data generation, analytics, transformation, data monetization, and then actual financial services built on that data as well. And I'm going to touch on some of those as well. So how do we go about it? Just recapping, you saw this slide earlier, this diagram earlier from JV. But the point being is that we're actually meeting developers where they are. So the Filecoin, the FVM, the hypervisor, is a polyglot, it's a multilingual runtime that's based on WebAssembly, WASM. And the first runtime that we have actually released is the Filecoin Ethereum virtual machine that runs on top of FVM. And the idea behind that being is we're meeting developers where they are in the ecosystem. They can use the existing tools, the existing languages, the existing libraries that they're used to using now on Filecoin. And that is just, like I said, the first runtime. It's language and blockchain effectively agnostic, so we could create other runtimes on top of there. So in the future there may be, for example, a Solana runtime that could run on there, or you could create something like a Flow runtime, or any of the other blockchain runtime smart contract platforms that you wanted to build, you could now implement on top of Filecoin as well. And we have all things like the low-level access control, and we use the native data structures that are used within the Filecoin network. So things like IPLD, which is how we represent data within the Filecoin ecosystem. So for the first time now, developers are able to actually interact with the Filecoin protocol on-chain. So they were able to interact obviously with Filecoin from an external point of view, but now they're actually able to write stuff that interacts directly on-chain with the primitives that we have on-chain. They can write stuff in Solidity, have it compiled down, and then run actually on the network and interact with what we'll call the built-in actors that I'll cover in a little bit. So what we've done is we've implemented the Ethereum JSON RPC endpoint. So Lotus, which is the reference implementation of a Filecoin protocol and a node, now supports the Ethereum JSON RPC. So this means you can immediately use all of the tooling that you're used to using, Hardhat, Remix, Foundry, MetaMask. You can use those all with Filecoin. As far as they're concerned, you're just talking to another Ethereum network. And so we've got a number of endpoints as well, and you can find us on, if you go to chainlist.org, type in Filecoin, you'll find it listed on there, and you can click and automatically get, for example, MetaMask configured on there. In terms of actually interacting with the Filecoin protocol, you might have noticed that Jonathan mentioned that the actual base FVM was actually went live about, well, middle of last year. And what we did was we took the inbuilt system actors, the inbuilt smart contracts that power the actual underlying way in which Filecoin works, and re-implemented those on top of that FVM runtime. So the actual FVM runtime has been running actually, getting on for the best part of a year now on the blockchain. The thing that we've launched now is the ability to do user programmable smart contracts and allow everybody, any developer, to now deploy smart contracts on top of that. And listed here are a number of these inbuilt actors you can interact with. So things like the storage market actor allows you to interrogate storage provider deals and find out, okay, who is storing, if I've got a deal ID, can you actually verify that this data is actually stored and live on the network? And that is really a key part. So a lot of people think about Filecoin in terms of decentralized storage, but there's an element that we sort of get for free as part of that actually is in some ways much more important, and that's the verifiability of the storage. And the fact that you can actually inquire on the blockchain about a storage deal, and you can have certainty that that data is actually being stored. Every 24 hours, a storage provider has to answer a zero-knowledge proof that proves that they still have your data. So that means that you can have that assurance that you don't get with any other, even the centralized systems. If you go and ask some big centralized service provider for your data back, you hope they've still got it, and the chances are they will do. But in this case, we now actually have provability of that. And that becomes a very important point I'm going to touch on in a bit in terms of what you can then build on top of that. Oh. So like I said, any developer can now build on top of that, and there's several kind of components and several classes of things that we're seeing built on top of Filecoin. So some examples here, things like perpetual storage of NFTs. Many people know, if they've been dealing with NFTs, the majority of NFTs use IPFS for referencing the actual assets of the NFT, because that gives you that verifiability of the integrity of the data. But now you can add on top of that the availability of the data as well. So with perpetual storage of NFTs, you could actually have a smart contract that when a storage deal comes to the end of its life cycle, could automatically renew that storage deal for a further period of time. We have things like data DAOs, in which you can have a collaborative group of people that come together to fund the storage of data, maybe even vote on what would be stored, how long it would be stored for, how much they're willing to pay for that storage. And Filecoin staking. Again, this is part of the economy side, and I'm going to touch on that in a little bit. So some examples of what people are building. NFT storage. Again, these people are behind some of the largest NFT marketplaces on the internet at the moment. They have a project called NFT Forever, doing what I just mentioned about auto-renewing NFTs using an FEM smart contract. Glyph, who are known for creating one of the wallets within the Filecoin ecosystem, Glyph have a staking pool service. This allows individual holders of the FIL token to stake that token in a staking pool that could then be borrowed from by storage providers. So if you set up as a storage provider, you need to provide a certain amount of collateral as part of that business, and that can sometimes be a friction point for new storage providers starting up. But they're now able to borrow against this staking pool. And again, what is interesting is that all of this underneath, at the very lowest level, has a substantial amount of hardware underneath the underneath all of this, like DeFi services that are underpinning it. Saturn. So Saturn is a content distribution network, a decentralized content distribution network you saw in the last, mentioned in the last talk. They're using FEM for dealing with the payouts to the node operators. So if you, an individual, operate a node on Saturn, which any of you here in the audience can go and set up a node on Saturn, you'll be rewarded based upon the amount of data that your node serves up, the amount of traffic that your node services. And they are now using FEM to deal with the payouts. So as a node operator, you can go to a particular site, and there's a smart contract there that holds your funds and will release the funds to you periodically when you go there. DeFi staking and loans. So again, I mentioned about how one of the things FEM is enabling is a whole economic system within the Filecoin ecosystem. And one area where this gets very interesting is that you can actually verify the income streams that storage providers have on chain. So as a storage client, when you ask a storage provider to store some data for you, there will be a fee for storing that data. That fee is actually put into an escrow and then released to that storage provider over the duration of that storage deal. Now, you can actually look on the blockchain and you can see that, and you can verify that income stream. So storage providers are actually able to borrow against future revenue that they have provably, on the network. So a bit like invoice factoring or whatever in the traditional business world, but again, underpinned by an actual verifiable, record on a blockchain as well. Lighthouse is a storage aggregator on Filecoin. So the Filecoin storage providers are generally optimized to store large amounts of data. What happens if you have a smaller amount of data or want an intermediate, kind of nicer interface, more friendly interface perhaps to get to the data? Then Lighthouse is one of the options that allows you to do that. And they are using FEM to do perpetual storage of that data, auto-renew storage deals. Lighthouse also offer things like encryption as well and access control to the data as well. And they're using FEM to power some of that functionality. I mentioned data DAOs, decentralized autonomous organizations, but focused around data itself. So Lagrange and SpendDAO are two examples of projects that are storing large scientific data sets on Filecoin, and they're actually allowing people to, like I say, collaboratively fund those data sets. So imagine you're a researcher, you have potentially several research bodies that are funding your work independently. Well, they could collaboratively fund the long-term storage of that data using something like a data DAO. Or you could even extend it and have almost like an endowment type policy. Maybe the DAO even in itself, actually, maybe the DAO stakes the funds in one of the staking systems, generates a return, uses that return to pay for the long-term storage of the data. This is what I mean about the composability that is now enabled by FEM. And another really interesting area is where we combine the on-chain and the off-chain. So there's a project called Bacalhau within the Filecoin, well, within the Protocol Labs ecosystem. And Bacalhau is a off-chain compute network. So with FEM, it's an Ethereum-compatible virtual machine. You're generally running smaller compute jobs in which consensus is an integral part. But what if you want to run something pretty substantial, like a machine learning job or something like that? Well, this is where Bacalhau comes in. And then using FEM, they're able to actually combine the on-chain and the off-chain. So they have a project called Lilypad, which is a bridge between FEM and Bacalhau. So you can have a smart contract. So in this example, they're using the Stable Diffusion AI model that generates an image from a text prompt. You can have a smart contract on FEM, emit a text prompt that is then picked up by Bacalhau, that then runs it on a decentralized compute network to run that compute job, comes back with an image. That image might be stored, say, on IPFS. That returns the IPFS CID back to the smart contract. The smart contract could then mint an NFT that points to that, that data, that image, and you've kind of gone full circle there. But what you've got then at the end of it is, again, a verifiable kind of stamp, in this case an NFT, that points to that data there. I'm talking a bit about sort of tooling and ecosystem here. You're able to use Filecoin with MetaMask. Like I said, it just looks like any other standard Ethereum network. You can go to chainlist.org, search there for Filecoin, and you can configure MetaMask to connect to the Filecoin network. We have a number of test networks. We also have the ability to run a complete local network on your laptop as a developer. You can do that with a Docker image that sets that up and gets that running locally for you, so that you can actually test both sides of the interaction and play both a storage client, and you can also play a storage provider as well and work through that process together. Remix, which is a popular web-based IDE, again, you can use that. It works with MetaMask, what are called injected providers, and so you can use that and take a standard contract. OpenZeppelin, for example, has a whole library of contracts that have been audited already, and they've got a fantastic contract wizard. You can go into the contract wizard, set up a contract for something like an ERC20 token for a fungible token, or ERC721 for a non-fungible token, and you can hit deploy to or open in Remix, open it up in Remix, change the network to Filecoin, and hit deploy, and it's then there on Filecoin. Similarly, Hardhat, which is another tool that a lot of people use. We've got Hardhat starter kits as well, so developers can actually download that, and it gets them all started with using Hardhat. And we've got a bunch of example contracts on there that you can use, including a contract that is called the deal client contract, and it enables a smart contract to act as a storage client and kind of take you through a lot of the process of negotiating a storage deal programmatically. And we've got a set of Solidity libraries as well to interact with it as well. So these libraries give you a higher level access to the inbuilt actors that I mentioned earlier. So you can query things like the status of deals, how much power a miner might have, what funds are available here and there, and also some of the incentive mechanisms. So we've got a system called Fill Plus, which is an incentive mechanism for storage clients, and you can interact with that as well through these Solidity libraries. So there we go. That was a roundup of FEM. Hopefully you found that useful. And as Jonathan said, there's a bunch of us over kind of sort of that direction over there in the booth. So if anybody wants to come and talk a little bit more or dive into a bit more of the technicals, then you can find us there. We also have a number of hackathons that we have running, and we have one that is starting actually the start of May called the Dataverse Hackathon. And so if you're interested in getting involved in that and developing and building upon that, we have a fairly substantial prize pool as part of that hackathon. So that's going to be starting on the 1st of May. And yeah, there's a link there, either a QR code or there's a Linktree link there that will give you a link to all of that, including the hackathons that's coming up. So there we go. Thank you very much.